A diesel pile hammer is a heavy-duty machine that uses a diesel engine to drive piles into the ground. It's used in construction projects to build bridges, skyscrapers, and other infrastructure. Heavy construction is unimaginable without a diesel hammer. So without further ado, let's jump into the main topic of how this machine works. Diesel hammer is a separate machine. This is the top beam, which holds the entire machine. Undercarriage. And this is the hammer. You will be surprised to know that the weight of the hammer ranges from 10 to 25 tons. It is used according to the scale of the project. And at the bottom is the cap. These two are the guide rods, which connects the cap and the top beam together. At the same time, they allow the hammer and the undercarriage to move only up and down. This is the guide beam, which guides the top beam. As a result, the top beam can move up and down. There are stairs on the guide beam for workers to climb up if necessary. The guide beam is moved up and down through the pulley system. And the hammer is lifted through the undercarriage, which is controlled by a completely separate pulley. This is the boom. With the help of this support structure, the top beam, pile and undercarriage are moved as needed. All this power comes from the crane machine. Let's see how the hammer machine works. First, the top beam is raised as required. Then the pile is lifted, and the cap is placed on the pile. Now it is time to lift the hammer through the undercarriage. You can see that the hook in the undercarriage locks the hammer. As a result, the hammer starts moving up with the undercarriage. Next to it is the lever balance hook. It always maintains its position under the pressure of the spring. After the hammer is raised sufficiently, the end of the lever is pulled. As a result, the lever exerts force against the hook, and the hammer is unlocked from the hook and starts falling down rapidly due to the effect of gravity. And hitting the cap, the impact force is transferred to the pile. Now the question is the hammer constantly lifted up and released manually in this way? The answer is no. If done manually, it will take a lot of time to insert each pile. So how is this automatic operation possible? You can see that there is a cylinder in the center of the hammer, which is completely airtight. On the opposite side, there is a piston in the cap. In the center of the piston is the fuel injector. The function of the fuel injector is to complete the combustion process by spraying fuel when the piston reaches the highest point inside the cylinder. This is the fuel pump, which is connected to the fuel injector through a pipe. When the fuel pump is pressurized, fuel is sprayed through the injector. Now the question is how the fuel pump works. This is the fuel tank. The complete model of the fuel pump is shown here. You can see that the fuel pump is immersed in the fuel. There are two one-way valves on both sides of the pump, which can only be opened in one direction. The valves are usually closed all the time due to the pressure of the spring. When the piston of the fuel pump rises, negative pressure is generated inside it, and the valve on the left side opens, while the valve on the right side closes tightly instead of opening, since the valves are one way. As a result, fuel enters the pump from the tank. Then the negative pressure inside becomes neutral, and the valve on the left side closes again. Now we push the piston. As a result, positive pressure is generated inside, and the valve on the right side opens, while the valve on the left side remains closed. As a result, all the fuel inside the pump is ultimately sprayed through the fuel injector. Now let's see the complete process. We know that any object is empty. That means it is filled with air. When the hammer is released from above, it starts to fall down due to the gravitational force of the earth. While going down, the air inside the piston cannot escape due to the airtight of the piston and cylinder, so air starts to compress. As the pressure increases, the temperature also increases. Finally, this temperature reaches about 250 to 300 degrees Celsius. In this situation, fuel is sprayed. Diesel is used as fuel here. Diesel ignites itself at a temperature of 210 degrees Celsius. Therefore, as soon as fuel is sprayed at a temperature of 300 degrees Celsius, the fuel inside the piston catches fire, and the temperature reaches about 600 to 700 degrees Celsius. At this high temperature, the compressed air evaporates and expands rapidly, As a result, tremendous pressure is generated inside the piston that the hammer is finally forced to rise again. Now the question is, after the fuel is ignited, how is such a huge pressure generated that it is capable of lifting the 10-ton hammer? For that, we need to understand the basics of physics. For example, when any substance is heated, it expands. Similarly, when water is heated, it starts boiling at some point. And when it is heated further, it turns into steam. If we completely convert 1 liter of water into steam, do you know how much space will be required if the steam produced from 1 liter of water is kept at normal pressure? 10 liters of space or 100 liters? No, to keep the steam produced from 1 liter of water at normal pressure, about 1700 liters of space will be required. That means such a huge vessel is required to keep the steam produced from 1 liter of water. Now, if we make this vessel equal to 1 liter, can you imagine how much pressure will be generated inside it? Similarly, when it catches fire inside the piston, the air expands excessively and generates tremendous pressure. There are some ports at the edge of the cylinder. As the hammer passes the piston, exhaust gas is released through these ports at high speed. Due to the rapid release of gas, a vacuum is created inside the cylinder, which means negative pressure is generated. Therefore, the surrounding air quickly enters the cylinder, and the cylinder is filled with new air. Due to the effect of gravity, the hammer falls down again and hits the cap with great force. The piston and cylinder are designed in such a way that when the hammer hits the cap, the piston and cylinder are at their maximum limit. That's when the fuel is sprayed, and all the previous processes are repeated. All this work is done so quickly that the hammer moves up and down 50 to 60 times per minute, and it is possible to drive the piles into the ground very quickly. Now the question is how to spray fuel when the air inside the cylinder reaches the critical moment. A bent arm is used for that. When the bent arm is rotated, it presses on the fuel pump and fuel is sprayed. You can see that a hook is attached to the hammer. When the hammer goes down, the hook pushes the bent arm, resulting in fuel spray. In this way, fuel is sprayed at the critical moment. So how is the machine stopped? An adjust lever is used for that. The lever is initially tilted to the right by the pressure of the spring. When the machine needs to be stopped, the adjust lever is turned to the left. You can see that the rod attached to the adjust lever turns the band arm. Now, even though the hammer goes down, it cannot hit the band arm, as a result of which the fuel does not spray, and the machine stops. I hope you have understood how the diesel hammer machine works. If you like the video, then definitely do not forget to subscribe and like the channel and turn on the bell icon next to it.